So in this particular video I will be discussing about the dynamics of circular motion which is non-uniform, right? So we will study about the dynamics of non-uniform circular motion, dynamics of non-uniform circular motion, non-uniform circular motion. So basically when we see the circular motion which is non-uniform, right, which means the acceleration is not constant, which is obvious because the velocity is changing at each and every point on the circle. Now the particle here given is doing some rotations, right, periodically. So when I take any random point, let's say this one, right, for example, this is some random point that I've taken. So I need to find the forces that are acting on it, and this black arrow is called the string. This is the string, right? So string of any kind would have tension on it, right? Okay. So if it is having a tension, then we can resolve the forces into vertical and perpendicular components, right? So how we'll do it? Let's say, let me just rub this. Okay. So we need to resolve, right? Okay. So basically let me complete the diagram and then I will show what we can do, right? Okay. So this is the complete diagram. There are basically 3 points where we need to find the derivations. So the first point is, let's say this is the lowermost point, so we'll label it as L, right? This is the highest point or the highest height which the particle can achieve, so I have labeled it H. And let's say it is this line, this particular line reaches till point M. These are four important positions that we need to consider. So this is position 1, this is position 2, this is position 3, and this is position 4. So while the object is circulating on this circle, let's say the radius of the circular orbit is R, this one is R, this one is R, and this one is R. And let's say mass of the object is M. Let's say mass of the object is is M. So basically this is the object, and the mass of the object is obviously 1. So there are basically the force which is acting downwards is mg, right? So this is the force which is acting downwards. Okay, let's say this is the angle between the two radial vectors, this one and this one. Okay, so let's say this is the mean position, or this is the position where the velocity of the particle is the highest, right, and the tension is largest. So one thing that we should take care of the fact is the tension on the string is always acting towards the center, right? The tension is always acting towards the center. This is the tension, this is the tension here, this is the tension here, right? So what we have to do here, we have to resolve mg. So we have this vector and this vector. If this is theta, then this is also theta. So this vector is mg cos theta, mg cos theta, and this vector is mg sin theta, mg sin theta. Okay, so what we can do is, if the object has to rotate in this particular orbit, so what is the minimum tension that is required? So the minimum tension is, we need to balance the forces. So how will you balance the forces? See, basically I have T should be equal to T is equals to mg cos theta, but in this equation we have missed one term. What is it? So see, to rotate, for a particle to rotate in a circle, we need a centripetal force. So centripetal force is always acting towards the center. So in this equation what I have to do is, I have to add one more force term, which is given by, let's say in this T plus mv square upon r, where r is the radius of the circle, v is the velocity at this particular point. So v is the tangential velocity at this particular point, v. So v is the tangential velocity at this particular point. So this is the force that we have to deal with, right? So right. Then what we can do, see, tension is the greatest force, so T minus mg cos theta should be equal to mv square r, because mv square r, this is the centripetal acceleration, or centripetal force, sorry, right? So this is the centripetal force which is required for any body to rotate in a horizontal plane. So T is the tension, right? T is the tension, and minus mg cos theta should be equal to mv square upon r. Then and then only the object will give me the rotation, right? So here I have a trigonometric function cos theta. So what, let's say I want to find the value of T. Let's say T minimum. T minimum means the minimum value of tension with the help of which the object can rotate, right? So it will be equal when cos theta is minimum. When cos theta is minimum. So the minimum value of cos theta is -1 for theta equal to 180. For theta equal to 180, right? If theta is 180, then T minimum will be at point H. So this is 0, and theta keeps on increasing like this. So when the object reaches at point H, at this point tension is minimum. Tension is minimum because here theta is equals to 180 degree, right? Okay, so if we substitute this value in this, so we will get T minimum is equals to mv square upon r plus mg cos 180, mg cos 180, that is equals to mv square upon r minus mg, because cos 180 is -1, right? So if we want to find the value of v, right? So this is, see, basically this is the value of T minimum, the minimum tension, right? So let's say this is equation number 1. This is equation number 1, which is quite obvious, right? I hope you have understood it, right? Okay, so what next we have to do is, see, I have already told you that there are 3 main positions. This is L, this is the position 2, this is position M, and this is position H. Now we'll see, we will take consideration the conservation of energy. Conservation of energy. So according to conservation of energy, at this point L, the particle is having only kinetic energy, right? And the velocity at this point is let's say VL, and at this point the particle is going in this direction, so velocity is VH, right? So according to the law of conservation of energy, right? According to law of conservation of energy, what we can do is, the energy at this point should be the energy at this point. Now the energy at point L is only kinetic, so half m VL square is equals to half m VH square plus the potential energy, because the distance from this point to this point is 2r and potential energy is mgh, therefore m into g into h is 2r. So this is the second equation with the help of which we can find the velocity at VH. Now what we can do, how we can find the velocity V here, or the velocity VL. So for T minimum we can find VL. This is the T at T equal to T minimum, VL is the VH is the VH is the minimum velocity, so we can find the value VH. So VH will be maximum only when this term is greater than or equal to 0, right? So if this term is greater than or equal to 0, then and then only we will get the full rotation without any slack. So from this equation we can clearly see that if this tension is greater than or equal to 0, then and then only we can see, right, if the if the particle is rotating or not. Otherwise the particle will not rotate and will get a slack in the string like this, right? So how we'll get mv square, and I will write it mh square upon r minus mg is greater than or equal to 0. So what we can do is we can do vh square upon r is greater than or equal to g, that which implies m and l will get cancelled out, because on the right hand side we have 0, right? So vh square is equals to g into r, which implies vh is equals to root gr. So this is an important equation that we should take care of, right? So vh is the velocity at point h. So this is the minimum velocity with which if the particle rotates, the string will not have any slack at this point, right? So with the help of equation 1 we have found the value of vh. Now if we want to find the value of vl, we can substitute the value of vh here, right, in equation number 2. So let's say I will copy it down in the next slide. So equation 2, let me copy the equation number 2, half mvl square, half mvl square, wait, where is this equation? Okay, I will copy it down here, half mvl square equal to half mvh square plus 2mg into r, and we have found the value of vh to be root gr, right? See, m will cancel out from all these equations, m will cancel out, and m will cancel out. So we are finding the equation of for velocity at this point vl, given that the velocity at this point vh is equals to root g into r. This is the mass, this is force mg, this is mg cos theta, this is mg sin theta, this is theta, so this is also theta, and we have seen here at this point. So we'll take this case also, right? So how will I find mvl? So vh is given as gr, so vh square equal to gr. So what we'll do, we'll say we have vl square is equals to 1 by 2, vh square is g into r plus 2g into r. So vl square, let's say I will multiply all the equation by 2. Let's say I will multiply this equation by 2. So we'll get vl square is equals to gr plus 4gr. So I will get vl is equals to root 5gr. So this is the value of velocity at the point L. So at point L I will have maximum tension, right? And when the tension is maximum, the velocity is root 5gr at maximum tension, for maximum tension, right? For maximum tension, velocity vl is root 5gr. So the velocity here is gr and the velocity here is 5gr. So difference between velocity at point L and at point H is 4gr, right? Is 4gr. Okay. What else we need to find? We need to find the velocity at point M. So what is the velocity at point M? Again we will consider the energy consideration, the conservation of energy. At point M, using the conservation of energy, we have what we have. So here we have kinetic energy, so half vl L square, half mvl square is equals to, here I have kinetic and potential, so half mvm square plus mg into r, because the perpendicular distance from this to this point is r, so I consider mgr. So we know L, VL square is 5gr, we'll just substitute, we'll cancel out m, we'll cancel out m, and we'll cancel out m. I will solve it here only. So, and let's say I will multiply whole the equation by 2. I've multiplied the equation by 2, and I will substitute the value of VL from this equation, right? Let me change the color so you feel a little interesting, right? So this is half. What is VL square? VL square is 5gr. Since I have multiplied, okay, I will just multiply it by 2 and then we'll cancel it. Is equals to half Vm square plus gr, right? And I've multiplied the whole equation by 2, so I will get 5gr plus, this is equals to Vm square plus 2gr, because I have multiplied by 2, so Vm square is equals to 5gr minus 2gr, which gives 3gr, which gives Vm equals to root 3gr, which gives Vm equal to 3gr, right? Okay, so this is the basic derivation of how we can find the velocity at the lowest point at point m, or at the distance at point m, capital M, and at point h, which is the highest distance. So corresponding to each velocity we have the value of tension, right? So corresponding to each velocity we have the value of tension, and how we can find the velocity of tension? We can substitute the value of Vm, Vh and Vl in this equation, this one. So substituting the value of Vm, let's say, okay, so for point L, cos theta equal to 0, so this term will become 1, right? This will become 1, and we'll substitute the value of VL here, right? Acha, so we'll find the tension at point L. Okay, at point M, theta equal to 90 degree, so we'll substitute the value of theta here, which is cos 90. So cos 90 is 0. We know the value of Vm, we have found this one, so we'll substitute the value of Vm in this equation, and now at this point we have cos 180 equal to -1. We can substitute the value of Vh here, and I can find the value of tension, right? So this is the derivation that I wanted to make a video on. So thanks for watching. I hope you would have understood. Thanks.